All right, welcome to the final video for Unit 10, Part 2. Here we're going to apply the special trig limits that we just talked about and do some applications. Like, for example, here, the limit as t approaches 0 of tangent 5t over 3t. Well, remember, we're going to want to use the fact that the tangent theta over theta is equal to 1. So we're going to say the limit as t approaches 0 of tangent 5t over 3t. Now I'm going to want to get it so that I have the same number, like I had 5t over 5t. So what I'm going to do here is I'm going to multiply the top and the bottom by 5, numerator and denominator. So that gives me the limit as t approaches 0 of 5 times tangent 5t over 5 times 3t. So the reason why I did that is because if you look at here and understand that if t approaches 0, then I can also say as 5t approaches 0, because if t approaches 0, then it's assumed any number times t also approaches 0. So that allows me to split this up here as the tangent of 5t over 5t times the limit as t approaches 0 of 5/3, because the 5/3 would be the left over. And since I know that the limit as the tangent theta over theta is equal to 1, and then the limit as t approaches 5/3 is 5/3, so therefore this is equal to 5/3. All right. Same thing for number 2. So the limit as x approaches 0 of sine 4x over x. So I'm going to multiply the top numerator and denominator by 4. So it gives me the limit as x approaches 0 of 4 sine x, 4 sine 4x over 4x. So then that equals the limit as 4x approaches 0 of sine 4x over 4x times the limit as 4x approaches 0 of 4. And so we know sine theta over theta is equal to 1. So that's going to be equal to 1 times the limit of any constant is just itself, so 4. So it's equal to 4. So same thing for number 3. Now here, we're going to say the limit as x approaches 0, sine 7x over 6x times, and now we're going to multiply top and bottom by 7. So it's going to equal the limit as x approaches 0 of 7 sine 7x over 7 times 6x. So now the limit as 7x approaches 0 of sine 7x over 7x times the limit as 7x approaches 0 of 7/6. And then that's just going to equal, well, sine theta over theta, remember, is 1 times 7/6, which is 7/6. And last but not least, here we have 2 of them. So this is basically, we have sine 8x over sine 5x. So the limit as x approaches 0 of sine 8x, and I'm just going to put over 1 to kind of know that it has a fraction, and times 1 over sine 5x. So we're going to use we're going to have to get an 8 on the bottom here and a 5 on the top there. So that means we're going to have to multiply by 8 over 8 and by 5 over 5. And we need an x to go with those numbers. So that means that we're going to have the limit as 8x approaches 0 of sine 8x over 8x times the limit as 5x approaches 0 of 5x over sine 5x times excuse me, the limit as x approaches 0 of 8/5. So the limits of these are 1, 1, and then 8/5. So the answer is 8/5. Now, you can probably see a pattern. And I'm writing this out because I want to make it clear. You can probably see a pattern without doing the work. However, you do or will have to show all the work. So you should know what the answer you're trying to get is, but you got to use the limit rules and the special trig limits to find that answer. So your work is going to be just as important as the overall answer. All right. Thank you for watching, and I hope you have a good rest of your day.